This is exam 2, page 9 to 10, section 7, and it's problems 6A through 6G. And I didn't write down the problems, so I have my thing right here. So the first one, here's the equation we're giving for position. So we're trying to find the first and second derivative, and the first derivative is velocity, so v of t, and then it's going to be 3t squared minus 24t plus 36. This is missing a t. Plus 36 of the first derivative, and then the second derivative of the position is acceleration, so v of t, and that's going to be 6t minus, should be 24. Oh, and this is 90. So there's your first and second derivative, and then b says if the first derivative is the velocity equation, when is the particle at rest? So what we're going to do is we're going to factor this, the velocity equation, and then set it equal to 0. So setting this, factoring this, we're going to do, first we'll set it equal to 3t squared is 24t plus 36 equal to 0. And what can we take out of this equation so far, or factor out? I factored out a 3, and then that's going to give me t squared minus 8t plus 12. I'm pretty sure. And then we'll set that equal to 0 still. And then I do the method, I don't remember what it's called, but I was shown this by Mr. E. So these two, we need something that multiplies to positive 12 and adds to negative 8. So adding to negative 8, we could do negative 2 and 6. So negative 2 and negative 6. And then we'll expand, and this will become, I'm going to erase this just so I remember. Negative 2 and 6. So then we'll do 3 of t squared, and we're expanding this. It's going to be minus 2t, and then minus 6t plus 12 equal to 0. Okay, and then after that, we're going to take out the 3, and then see what we can take out from these two. It's like little chunks. It'll be 3, and this should stay. It'll be t minus 2, and then it'll be a negative 6 that I can take out. So I'll do negative 6, and it'll be t, and then 12 divided by 6 is 2. So these are the same. So then factored form will finally be 3. Oh, no, 3. Oops. 3. Oh, I was right. T minus 2 from here. And then we're going to combine these, and that's going to give you t minus 6. That's your factored form, and it's still set equal to 0. So now the zeros you get is t equals 2 and t equals 6. Okay, and then question C, these are your zeros for critical values. But C, algebraically determine the intervals where s of t is increasing. So what we're going to do is make a sign chart with these values, So it'll be, this is a football angle. It'll be V of t, and then it'll be a chart. I'm gonna make it really small. And then our zeros are 2 and 6. So we're gonna have a value 2, 6. And then right here, we can do zeros here. So now we're going to choose a value right here, and that could be 1, so v prime 1. I mean, not v. V of 1, and this would be v of 5. And then this could be v of 7. And then you're going to plug in these values into the original, so the acceleration equation. And then if you plug in 1, 5, 7, you're going to just see if it's negative or positive, and you get positive, negative, positive, which means it goes like this, like this, like this. So, because 0, 2, 6. So basically, positives increasing, where S of t is increasing is going to be 0 to 2. The union, because there's 2 parts, and then 6, comma, infinity, and that's when it's increasing. And then D asks on which interval of time does the particle move the west direction? I made note that west equals left, and then what I'm going to do is the acceleration. So under here, I'm going to kind of line it up the same. Should have saved more room, but we also have to do our acceleration equation. There we go. 6t minus 24 is equal to 0, and then what you get is that t is 4. And this will be on the acceleration. So this is 4, and then we're going to go a1, and this will be 0. This isn't a part of them, and then we'll do a 5%. Then we plug those into our equation. This one, we plug in 1 and 5, and we'll get, this should be negative, this will be negative, and this will be positive. Then if you connect these, what you can see is when the signs are opposite, that's when it's going to be decreased, like it's not going to be moving west. So what we need is, what we see here is this part from here, from 2 to 6, this whole section, that will be when it is moving in the west direction, because it'll be negative velocity. So what I also did with this chart is we did this in class as well. I just drew like a little, say this is 0, and it's gonna go this way, and this way, and it's gonna go way to infinity this way. So the little section for when it's moving left is gonna be 2, 6 is west, and that's is west, and 2 vowels. Okay, and then for C, oh, I use an E. It's asking on what intervals of time does the particle have negative acceleration. So we just found negative velocity. So what we're gonna do is look back at our little chart here, and what we see is that it's negative and positive. T equals 4. What I did personally was setting, this is the acceleration chart, so I kind of just looked at it, so I didn't put it as like work, but when it's going to be negative acceleration, when s double prime of t is less than 0. So then what we're going to do, 16 minus 4 is less than 0 plus 24. We're going to get 60 over 6. We're going to divide it because we're going to have 24 over 6. And then this is going to give you t is less than 4. So it's going to be negative acceleration on the interval from 0 to 4. So right here. Because it also aligns up here. So it's going to be from 0 to 4 is when the acceleration. Okay, E, F. Using the information from A to E, determine the intervals in which the particle is slowing down. So for this, I thought about all the things we learned. We learned like if they're opposite signs, so say when we look at it, there's opposite signs from 0 to 2, right here and here, because it's positive, negative, and then from 4 to like 6. So really short right here because it's negative, and positive right here, and then not over here because they're both positive. So you can look at it, but another way to explain it is the different symbols, so, or opposite symbols. So EFT can be less than or equal to 0, but then EFT has to be less than or equal to 0, or /n. It'll be the opposite. VFT is less than or equal to 0, and then AFT is greater than or equal to 0. So the intervals, I already mentioned them, but 0 to 2, union, 4 to 6. These are the opposite symbols. Okay, now last one, G. This was the bonus. I didn't get this on the exam, but the total distance is going to be the absolute value of when it goes from, we're going to subtract s, the position of 2 minus s of 0, and we're going to add or s of 6 and subtract that from s of 2. S of 2 minus s of 0, absolute value because it's total distance, so it needs to be positive, then s of 6 minus s of 2, and then absolute value, and then this answer I'm not sure, but it ends up being 48. And that's it.